Here is a question on projectile motion. It is based on the concept of how we can think of a 2D projectile motion as a superimposition of two mutually perpendicular 1D motion. Here, if we consider this as our x-axis and this as our y-axis, we can think of this motion as a superimposition of uniform motion along x-axis and uniformly accelerated motion along y-axis. It is said that it returns to the point of projection after two collisions. Let us think that the diagram is something like this. Let us think that the trajectory of the particle is something like this. Now, think that it is going with a uniform velocity of u cos theta in x direction. If it is moving with such a uniform velocity, then before the collision at this point, its velocity will be u cos theta. And after collision, since it is given that the coefficient of restitution is e, so after collision it will become e times u cos theta, right? So here before collision its velocity will be e times u cos theta, and after collision its velocity will become e squared times u cos theta. So that is, I have labeled the velocities, and notice that the velocity along the y-axis u sine theta, it will change because acceleration due to gravity g is acting downwards, but it will not change due to collision because it is always parallel to this surface. If this is the surface, it is always parallel to the surface, not normal to the surface. So it will change due to gravity but not due to collision. So for y-axis we can assume that the collision is practically not happening. When we are analyzing the motion along y-axis, then we can assume that the collision is practically not happening. So along y-axis, if I take the projection, so it will be something like this. This will be the kind of motion along y-axis. Now let me label some time intervals. See, if I consider the time at this to travel this path as t1, the time travel taken to this path traveled is t2, and the time taken to travel this path is t3. So I can label these times here. See, say this is t1, and suppose I am labeling it just randomly. I am not taking care of whether the diagram is accurate or not. I have just labeled it randomly. Say this times is t1, t2, t3. What I know for sure is t1 plus t2 plus t3 is the total time of flight is equal to 2 uy divided by g. Why? Because I have told that we can assume that practically collision is not happening when we are analyzing from y-axis. So we calculate time by analyzing motion from y-axis, and then we can say that the collision is practically not happening for this question. So it will be 2 times uy by divided by g. So 2 u sine theta divided by g, that is the value of t1 plus t2 plus t3. Now see that what is u cos theta times t1. See, this is uniform motion. There is no acceleration along x-axis. Since there is uniform motion, u cos theta times t1 is equal to r, right? Now what is e times u cos theta times t2? That is equal to 2r. And what is e squared u cos theta times t3? That is equal to r. You can see from this diagram. Now when we know the value of t1 plus t2 plus t3, so I can write it as 2u sine theta divided by g equal to what is t1? It is r divided by u cos theta plus 2r divided by e u cos theta plus r divided by e square u cos theta, right? So what I get that 2u square sine theta cos theta divided by g equal to r into 1 plus 2 by e plus 1 by e square. I just took the u cos theta here to 2u square sine theta times the cos theta, and I wrote it as r plus 2 by 1 by e plus 1 by e square. 2 into 1 by e plus 1 by e square. So let me write it here as okay, let it be like this. So u square is coming out as gr into 1 plus 2 by e plus 1 by e square divided by sine 2 theta, and u is just the root of this. So this is the required answer for this question.